Hello, hello. Great to have you here. So today we will talk about some amazing new topics I have prepared. We will talk about a new and very modern and lightweight way of using Angular and the NgRx signal store. And for this, we will have a look into the new signal forms. We will have a look into with resource that connects the resource API with the store. And we will have a look into our new mutation API, the missing link. We have resources for fetching data, for updating data. We have currently nothing official on the same abstraction level, and this will change with this mutation API. So before I start, let me double check if everything is fine. Yeah, looks good. So let's get started. So I will get started with an overview and motivation. For this, I will use two metaphors you might already know. If you follow me for quite a time, you will already know them. But the rest is new. The rest is live coding using the NgRx signal store, a very lightweight state management solution. We will use the new with resource that allows us to use the resource API in the signal store in a very streamlined way. We will use Angular's upcoming signal forms. They are currently experimental. And let's see when this experimental version lands in Angular. But here I'm using the current version of it from the Git repository of the Angular team. And then, as mentioned, we will look into this new mutation API, the missing link, as I call it. And at the end, it's your turn. At the end, I will answer all your questions. So feel free to ask all your questions in here, and I'm happy to pick them up. Just use the chat. I will go through the chat at the end and give you answers. And as mentioned, for most parts here, I will go with live coding. Live coding is a bit difficult for the overview, and it's a bit more difficult for the Q&A. So in this case, there is no live coding, obviously. Okay, so let's get started with two metaphors. One metaphor is that we usually see our application code as a script when playing theater, a script telling us do this and do that, say this, say that. Start crying, start running, do something like this. And this metaphor is completely fine. It shows that in traditional programming, we focus on the control flow. However, there is another flow that is more important when it comes to reactive programming. And if we are going with signals, then we have to switch over to reactive programming. And this view is a bit more data flow centric. Not the control flow is now in the center, but the data flow. And a good metaphor for this is a marble run. A marble run where several marbles go through. Those marbles represent the flow of our data. The flow of our data, and the data is represented by signals. And as you see here, the data goes through the system, and sometimes the data can be changed. One marble can be exchanged by another marble. Or perhaps one marble is split to several marbles, or several marbles are joined to one marble. We call this a computed, for instance. And at the end, some marbles are coming out that are presented to the user somehow. Usually we go with data binding when presenting data to the user. If we need to present the data using a form, we can use signal forms eventually, which is this new API we will cover today that is taking this marble that is coming out here and representing it in a way we can data bind to a form. And sometimes we need to call a method. For instance, if we want to display a snack bar, a toast message, then we need to call a method. For this, we have effects. So if we want to look at this marble run, which is, by the way, called the reactive graph in our system, then we have to look at the construction of our signals, at the construction and at the interplay of all of them. Internally, Angular is really building a marble run with them, or to be more precisely, more technically, a so-called reactive graph with nodes and connections between those nodes. So here we have an original name and an English name. And both represents a marble that is going in here into our desert resource, which is a HTTP resource fetching data from this URL. For this, we need to pass some parameters. The parameters are sent over. Then the API behind this URL is fetching some data. And eventually, the data is sent back using a value. And then this value is put into another variable that's called deserts. And then deserts might go into another computed. Perhaps I want to combine it with my ratings or with the loaded ratings. And this results in rated deserts that can be displayed to the user, usually via data binding. So already here, you see several nodes and several inner connections between those nodes. The reactive graph, the marble run. And the thing is, and I really say it quite often, you really have to think in terms of this reactive graph. You should not think about signals as objects with a getter and setter. Technically, that is correct. But to really use them in the right way, you have to see them as a part of the reactive graph. Another issue you might run into when working with reactive systems, regardless whether those are signal-based or RxJS-based or something else, you might lose the control about your system. Because reactivity means you do something here, and this is changing something there, which has another effect over there. So that means you might end up with an incredible machine where one change is leading to another change that in turn leads to a further change, which was a nice game back then, in the 90s. But honestly, if your architecture looks like this, you really have an issue. That means you need to find a way to control your reactive flow. And for this, you can go with a store. Stores really help with this, even though their main purpose is a different one. But stores usually help with this because they enforce something you might know as the unidirectional data flow. Usually your component or some other system part is telling the store what they want to have. I say here we are mentioning our intention. I'm using intention as an abstract term here because the technical implementation of this intention differs from store to store. In the traditional Redux world, the intention was about firing an action, standing over an action. When we go with lightweight stores, it's quite often about calling a function or a method. When the store knows what we want to have, the store is performing some actions, synchronously or more often asynchronously, like the Duracell Rapid from the advertisement. And this action is resulting in new state. This state is stored in the store because this is what stores are doing, but also with some reactive means, those changes are sent down to the component, to the same component or to a different component. And on this way, we might project those values with computed. Sometimes we might project the values up there to calculate something in there, adding the value added tax to your price, something like this. And sometimes it's more component specific than you do the computation down there. Something like defining a nice background color that clearly shows the state of your record. Is it deleted? Is it processed? Is it new? Does it need to be approved? Something like this. What we get out of here is our so-called view model. The reactive community, especially in the world of RxJS, we call this a view model, which represents our state for a specific view. Perhaps the state is, well, we have flights and tickets, and the view model is about tickets with flights or flights with tickets, or just the flights with the amount of tickets we have there. So here we are projecting to what we need for displaying to the user. The nice thing about this is it really helps us to manage the reactive flow. It helps us to prevent an incredible machine, because now for each and every user interaction, or let's say event, does not need to be a user interaction, we go one cycle here. We go upwards, to the right, and downwards. And that's it. That's it. So it's really easy to reason about what's going on here. Just one cycle per event. So at the end of the day, we can use the store for two reasons. The more obvious reason is managing state. We don't want to lose our state, and we don't want to put the state in a global variable, because, already several decades ago, we found out that global variables are not the last word on this. And the second reason is, as mentioned before, it allows us to avoid an incredible machine. It streamlines our whole data flow. And this is what I will implement today with all those new APIs I have mentioned in the beginning. And for this, I'm just using two libraries in addition to Angular. I'm using the NgRx signal store, which is a wonderful state management solution, fully signal-based. It's lightweight and highly extensible. And this extension mechanism is something we are using in our NgRx toolkit that provides a lot of additional very in-handy features for the signal store. And if we look to the download numbers, well, we have here almost 250,000 downloads a week, which is quite a lot, making the signal store one of the most famous lightweight state management solutions in the Angular space. And then here we have about 40,000 downloads, which is also not nothing. Okay, so at this point of time, big thanks to all our contributors. Here we have the contributors that have contributed something we are using today. Rainer is, by the way, the maintainer, and he did a lot of work, a lot of hard work in the previous days to land all those new features. And also big thanks to the other guys here. I don't know who this guy is, but rumor says he has contributed the mutation API in the previous days together with Rainer, who did the code reviews. So, okay, let's talk about the building blocks we are using today. As mentioned, we are going to use the resource API, which ships with Angular. It's still experimental. We are using with resource to connect the resource API to the signal store. It currently ships with the toolkit. However, it's also a candidate for the signal store. Rainer is also part of the NgRx team. We have signal forms. It's also experimental and will be shipped eventually with Angular. To use it now, I just took the source code from the Git repository, which gives us a nice window to the future of Angular. And with mutations, ships with the NgRx toolkit. It's the missing link, because we have resources for loading stuff. We need a counterpart on the same abstraction level for updating stuff. At this point in time, a lot of credits to some people and groups who influenced our design of the mutation API. There is Marko Stanivirovic, who is the father of the signal store. And some times ago, he proposed a prototype for an Rx resource, and it also contained a mutation API. And this was really something that inspired us when we implemented this. We also reached out to Marco. And one more time, big thanks. And also DanStack Query had a mutation API before. And yeah, also sometimes we are looking into it to do a decision. So before we start, let me also introduce myself. I'm Manfred. I'm a trainer and consultant for Angular. I'm in the Google Developer Expert team, and I also do a lot of stuff in the Angular community. Usually, I help a lot of companies with workshops, with consulting and code reviews in the space of Angular for enterprise scale applications. I live in Austria. I do a lot of stuff in Germany, and I'm always happy to work together with people around the globe, sometimes remotely, sometimes on site, and to do nice Angular stuff there. Okay, so this was the theory part. Now I would say let's come to the practical part. I was really looking forward to this because I love live coding, and I hope you also love live coding because, as the ancient Romans said, in code veritas. Yeah, in source code we find the truth. So let's do it. Let's move over to my demo application. It's the infamous flight application, and it allows us to search for flights. For instance, if I want to go to Mallorca, from the metropolis of Graz to Mallorca, then we get some flights here. Graz-Mallorca, Graz-Mallorca, Graz-Mallorca. By the way, last week I was there, and one thing I learned about the name, Mallorca means the bigger islands. There are two islands, Menorca and Mallorca. And Mallorca, like nature, means the bigger islands, and Menorca, like minor, means the smaller islands. Really like this. Okay, cool. So now let's have a look into the source code. And here in the source code, you see we are already signal based. We don't start at 0 because signals have been part of Angular for quite a time. However, all our state is local to the component. That means if the component is destroyed, like now, also our data is destroyed. And if we go back, we don't have this data anymore. We don't even remember that we talked about Mallorca, the bigger island. So state is local. We need to change this. We need to put the state into a store like the signal store. And then somehow we want to display the state using a signal form, especially from and to should use the new signal form concept. And for loading our flights, we will use a resource. And so we have a nice, simple example that shows how everything fits together. So for this, let's first of all move to our flight booking store. Let me have a check here if everything is fine with the stream. I have here my back channel. Yeah, looks good. Okay, so what you see here is our signal store, flight booking store, and it's set up with the signal store function, which is returning a full-blown Angular service, a class, and this class is provided in root. Here I have with state and with methods. In the signal store, we call those things features. The idea is we start with an empty store, and then we augment this empty store with features. And some of those features provide some state, some of them provide some additional methods. Here we have the state. I'm just starting with a filter and from and to. And here I have my basket. The basket is remembering which flight was selected. It's basically a hash table, a record used as a hash table that is remembering that flight, let's say 50 is selected because it's true. The nice thing about the signal store is for all those things here, you get signals, and those signals are read-only for the consumer and writable for us inside the store. Encapsulation. Because usually we don't want that everyone can change all the state. It would lead to a disaster if we have this globally managed state that is changed by each and every component. No, changes need to be done in a well-defined manner, and for this we can provide some methods. With methods is taking the current store, and it's adding some additional methods. Here I'm adding update filter and update basket. So update filter is getting a new filter, new from and to, and if something changed, I will batch it over. For this, we have this standalone function state. We pass in the store, and we pass in a partial state, which is here our filter. So the partial state is just written over this here, which means internally the signals are updated. When it comes to update basket, it's very similar. I want to say, hey, the flight with this ID is now selected or not. And for this, I'm going with batch state, store, and here we add an updater function that gets the current state and returns the new state. So here we are doing nothing. We are just putting something from the left bucket into the right bucket, as we say in our dialect. But you can do more meaningful stuff, like creating a new state that is a clone of the old state, a new basket that is a clone of the old basket, and that gets, in addition, a new entry with ID pointing to selected. And by the way, we don't need to spread the state because we can return one more time a partial state that is just written over the fitting elements over there. Okay, so this was for getting our fingers warm. And now we will start with the real tasks. Now we will start with adding a resource. So for adding a resource, in former days, there was no official solution. Thanks to Rainer and the toolkit, we have with resource. And with resource is one of those custom features. And I think it's a very good example for how extensible the design of the NgRx store is. With resource, one more time, takes the store and returns some resources. Each resource gets a name like flights. And here I can now add a resource provided by Angular. For instance, the Rx resource. The Rx resource, if you see here, Rx resource comes directly from Angular core RSJX interrupt, and with resource comes from the toolkit. So the Rx resource starts with a parameter or some parameters. Everything I need to fetch data. And here I would say, well, I need from and to. From is store filter from. And to is store filter to. Internally, this here is used to tinker a computed signal. And every time this computed signal is changing, a so-called loader is triggered. In the case of the Rx resource, we have a so-called stream loader. And a loader gets loader params. and those loader params contain the current parameters from there, the current from and to value. So let's read this from to loader params. And then we can go on with from and to. We can send it to, let's call it, to a service. And the service needs to return a stream. That's why it's a stream loader, isn't it? An observable. So where to get this service now? Well, for this, there is a nice new feature that has been introduced, I think, with one of the former versions of the Signal Store. It was not part of the original, of the first version. It's called with props. And with props allows us to add arbitrary properties to our store. Everything you need, like my events, which might be a subject or I don't know, something like this. I'm using this here to get a service like a flight service. And to make sure the flight service is not visible to the caller, to the consumer of the store, we started with an underscore. And this shows how powerful the type system of TypeScript is. You can really say, hey, if it starts with an underscore, don't consider it being part of the public API. And also it shows one more time that the RxJS team is really, really good when it comes to using those possibilities. Okay, private flight service. And in there, I'm grabbing this flight service and I'm saying find. I'm passing in from and to, and this will now return a flight array. Awesome. This is my first resource. If you are saying now, well, most of the times I will call a method that is doing HTTP stuff. Yeah, this is also what the Angular team figured. That's why, meanwhile, we also have an HTTP resource. We will look into this in some minutes. But for the time being, let's go on here. Let's switch out to the flight search component. And now let's hook up our store. We have the store here. And now let's get all the data from the store, like from and to, or perhaps the entire filter. Perhaps we can get rid of from and to because the store was that nice of giving us a filter, which is another nice feature of the store. You can nest your state. Okay, so we are getting started with the filter. The flights array also comes from the store. And now look, because we added a flights resource, suddenly we have here several flights values. A flights value with the current value of the resource, a flight status telling us whether we are currently loading or if loading already has been done or if there was an error, something like this. As quite often we need to check for loading, there is this convenience facility, isLoading, which is just checking the status for loading. Has value tells us whether there is a value or not. If there is an error, there is no value. And the thing is, and that's now really important, you are only allowed to access the value when there is no error. That means later on, we need to do an if checking for the error or checking for has value. And only if this if is true, we are allowed to access the value. Otherwise, we get an exception. This was a huge discussion in the Angular team and also with the Angular team. But finally, the decision was to throw an exception because there is no value in the error state. And we also don't want to swallow the error. We don't want to go with silent catches, which have been proved to be ineffective for some time, I guess. Okay, So this is all the goodness we get for free just by setting up this resource here. How cool is that? Really smart design. And by the way, this is type safe. One more time, thanks to the TypeScript type system. So if you write here something down that is not there, TypeScript will complain. You see this critics. Okay, cool. We want to have the flight value. We want to get the basket. We want to get is loading. Flights is loading. We want to get the error. Flights, error, and so on. Okay. That means we are getting some data down from the store. And please note, here I'm saying flights value and not flights value. I don't want to have the current value. I want to have the entire signal to data bind it to my template. Because the template needs to know when there are changes to update. Okay, we will add the signal form in a second. But first of all, let's finish this here, this delegating. When it comes to search, well, I just need to update the filter. I thought we have here something like update filter. Did I throw it out? Update filter. It's here. This dot, oh, I forgot store. Update filter. And here we go with our current filter. A bit later, we will hook this up to the signal form because we want to have all the data that was changed by the user. And here, when it comes to update basket, well, we also delegate. And this already nicely shows the unidirectional data flow. We are sending up our intention, something happens up there, and then we are getting down data via a reactive mechanism called signal here. Okay, that's nice. And now let's talk about signal forms. I'm really excited about this, but please note they are experimental, which means a lot of water will go down the river before we get this ready for prime time. But as mentioned also before, this gives us a nice window to the future of Angular, and it shows how we will think our Angular application eventually. So let me set up here a filter form with the helper form. And here we can now pass in our filter. We pass in an observable, not an observable and signal. And now we get something, some form data structure where each and every field of this object can be data bound. From and to, for instance. If you look more closely here, you see there are squiggles. What are the error message is telling us? Well, it tells us, hey, you have something with from and to, which is good. However, it should be writable, which isn't the case, and which is not good. So the form really needs a writable signal, usually with an object, where each and every property can later be data bound to a field. On the other side, this is an issue because the filter from the store is read-only. By design, it's read-only. Everything we get from the store is read-only. We have encapsulation. We don't want that everyone can change our state. Because if everyone changed our state, we would lose control about the state and about why it's this way and not that way. This would open the door for a lot of bugs and issues. So by design, we get everything out in a read-only fashion. And on the other side, we need here a writable filter, because the form is data bound. When the user is changing something, changes are written back. So what we can do here is introducing a local working copy. And also for this, we have a nice building block in the world of Angular. This building block is the so-called linked signal. The linked signal, see it as a powerful computed with a local working copy. That means we are getting the data from here. This is the source of our data. It flows into filter. However, filter has its own local working copy. And when we write back to the filter, we just update the working copy. We don't update the source. We just update the working copy, which is precisely what we need here. We want to have the working copy, and at some point in time, we say, now use this to search our flights. Yeah, and that's it. So that what we get here is a field of from and to. And from and to will also be represented as a field. By the way, if you want to add some validators, I guess I need to do another webinar on details of the signal form. But if you want to add a validator, you can add here a scheme. And here you can then call your validator functions. So validators are really, really easy. Required, was it required? Yeah, Angular form signals. Or min length. Stuff like this. And this gives you actually the best of both worlds. It's very short to write, like with template-driven forms. And you have the full power of your object model, because you can augment everything with validators, even with custom validators. Plus, you can restructure what you get from the backend with computed. So the best of both worlds. Very concise, but you stay in control. Nice. So now let's connect update filter to our form. We don't need to do it because the filter has a local working copy, but I think it's a bit more direct also in terms of our Marvel run to here say this dot filter form give me your value. Okay. Nice. Now let's hook this up in the template. And for this, I'm switching out my forms module, an entire module, by just one directive, which is the control directive. All you need is the control directive. So let's go in here. And here we are switching out ngModel by control. It was a filter form dot from. So it's almost the same. Filter form dot to. Down there, I'm doing this check for an error. We should really do it, because otherwise we are not allowed to access the value or anything derived from the value. And yeah, here I'm just painting out the found flights. Cool. So I guess that's it. Let's try it out. Flights, Graz, Paris, London. Yeah, we have only flights for the biggest cities like Graz and London, or Graz for, I don't know, Vienna, or Graz, New York. Yeah, seems to work. By the way, if you look at this filter form, come on. If you look at this filter form, then you see you have here in this signal that returns the state of the form also nested properties for each and every of your controls, like from. And if you access from, you see you have the usual stuff in there, like is it dirty, is it disabled, are there errors, is it hidden, is it invalid, is it banding for asynchronous validators, and so on. And at the end of the day, you also have this value. So this is more or less the object model you are used to, the same names, but in a signal way. Okay, let me do one additional thing. Namely, I want to have this in a reactive way. When I'm changing grades and berries, I want to trigger immediately loading. And this can be done. But this, I would really want to have this here in the constructor. And I want to have the possibility to not pass in value, but value. I want to pass in the entire signal so that every time the signal is changing up there, the update filter method is updating the state so that the resource is loading data. And let's see, perhaps the Angular team will give us some building blocks for this eventually. There are some discussions about a mapped signal. However, so far we can leverage a feature by the signal store, a very tiny but powerful feature. It's called signal method. Just wrap your method in a signal method and pops your uncle. Suddenly, you can pass in an observable, a signal, or just a value. And if you pass in a signal or an observable, then every time a new value is emitted, the logic is triggered. This update filter is triggered. It might update the state, which in turn will update or trigger the resource loader. Okay, so let's check this out. We have Graz, we have Vienna. Yeah, seems to work. Frankfurt also works. Paris, no, we don't have Paris flights for what reason ever, but New York or Munich, yeah, seems to work. But we don't have any debouncing. And also this, the lack of debouncing caused a huge discussion. Because when we look into the Mendel model of signals, one big difference between the signal and the observable is the signal does not know about time. The signal does not have a notion of time. If you need time, for instance, for events, which is something that happens over time, you still need observables. Signals don't have the idea of time. However, the bouncing somehow deals with time. And that's why we had a huge discussion whether it's fine to debounce a signal or not. Recently, Alex Rickerbo from the Angular team published a function, a helper function that shows a nice way to debounce a signal. So I think with this, the discussion is closed. We are now away from a very Mendel level down to a pragmatic level. We need some way to debounce our signals. And to do this here, I have written my own helper. Let's debounce the filter. The filter form, yeah. Debounced filter is debounced signal And let's pass in the source, which is the filter form dot value. And let's debounce it by 300 milliseconds. And then we can use this guy here to trigger the store. So my implementation is not as smart as the one provided by Alex Rickaboe. You find it on social media. Mine is just using RxJS interrupt. I'm switching over to RxJS, then I'm using the bounce time, and then I'm switching back to the signal world. We need to convert between worlds 2 times, which might be okay-ish in most cases, but I guess the implementation of Alex is a bit more performant and a bit more thoroughly thought through. But yeah, good enough for our purpose. We now have the bouncing, Graz, Paris, and yep, I want to start in Vienna. Yep, I want to start in, I don't know, New York. Yeah, seems to work. Nice. So we have a first working example. We don't need mutations for now, because for now we are just searching for data, but mutations will come in a second. However, before we do this, let's improve our store a bit. Flight booking store. And here, let's switch out the Rx resource by an HTTP resource. Because usually we are searching for data with the resource, and this is done via HTTP, so why not use a more higher level building block? For this, the Angular team gives us the HTTP resource. You see it here, it lives in Angular Common HTTP. It's an integrated part of Angular. And here we are passing in a method returning a parameter. Returning a parameter representing our request. For instance, we need to go with the URL here. Let's go with our demo URL. So if you look there, just a bunch of flights. We can filter with URL parameters. Talking of URL parameters, we also need to pass them in. From is store filter from. And to is store filter to. And this should do the job. By the way, it would be nice to have some starting value so that we don't need to deal with null and undefined. And for this, I really love this default value option here. That means we start with this here, and once something has been loaded, we go with the real data. Yeah, I guess this should do the job. Let's check it out. There is some issue in there. Let me check. What did it say? Bang. It says we have an issue with flights. Yeah. I think I know what's going on there. I always forget about the type parameter here. Yeah, let's say this returns a flight array. And now we are in the green area again. And let's go from Graz to, I don't know, Vienna. Seems to work. Or from Graz to New York. Yeah, cool. Perhaps you're saying now, yeah, that is cool that we have this higher level building block. However, I don't want to know about protocol details, about API details in my store. It's the task of a data access service. And here you are right. For this reason, I assume that most people will sooner or later take here this HTTP resource, cut it out, and put it into a data service. Here I have my flight service. Let's add a function find resource. Find resource takes our filter from, which is a signal of string, and to, which is also a signal of string. Signal of string. And here we can return our HTTP resource. So everything we did before, and from is now directly a parameter, and we have the same with to. Yeah. So as in the past, where our find methods returned an observable of entity, now we are returning a resource of this or that entity. And so the caller does not know how this entity is loaded. They just get it. Another to-do. Let's go back here. Let's here say store, flight service, find resource, and let's put in our filter, store filter from, store filter to. And not the value, but the entire signal. That's important because, as mentioned before, in there we want to trigger the HTTP resource every time from or to is changing. So just passing in the current value would not be enough. We need to pass in the signal so that the resource knows when to re-trigger. Yeah, and now I think this already looks a bit better. Okay, cool. This is our first solution that is just loading data, not mutating data. By the way, if you have any questions, feel free to put them into the chat. I will address all of them in the end. So now let's add the last missing link, the mutation API for updating our state. To demonstrate this, I have here this edit button that leads to this nice form. And I want to implement save now. I want to make sure when I'm pressing save that something happens. Currently, exactly nothing happens here. So to implement this, let's go to the store that is responsible for the detail view. It's a flight detail store. You know, if you go with lightweight stores, very likely you have several of them. Perhaps one per use case or one per entity within a use case, stuff like this. And here I have already prepared some stuff. As before, we have a resource that is loading the current flight via its ID. We have seen this here in action. 10 Graz Vienna, some date, not delayed. And we have a method that is updating our filter, which is just the ID, triggering here the resource. So what we need now in addition is a mutation, something that is capable of changing or updating our flight in the backend. For this, I'm going with mutations, which one more time comes from the toolkit. And one more time, it's used in the same way. And in there, we can now set up mutations like save flight. And here the API is really symmetric. Instead of creating a resource, we are creating a mutation. Currently, we have two mutations. There is an Rx mutation, where you can provide your very own operation that is returning a data stream. Something like this here. Or you can even define your operator. You can say, well, I want to have switch map semantics or merge map semantics or concat map semantics. By default, we have concat map semantics because it's the safest solution, no race conditions and so on. And you even have an on error and on success handler. Usually you want to do something when you come back. So this is the Rx mutation, a very flexible one. You can do what you want in the operation, similar to the Rx resource. However, if you say, well, I'm mainly doing HTTP stuff, then you can go with the HTTP mutation. Here, instead of an operation, we need to define a request. And a request is nothing else than a method taking a parameter like, I don't know, like flight. And then this parameter is used to define an HTTP call. One more time, we need to set up an URL. You see the API is really symmetric to the resource, which was one of the design criteria. Demo, Angular Architects, IO, API, flat. And then we go with a method, which is post here. So in my case, post is doing an upsert, which is an insert or an update. Don't be mad at me if this breaks REST semantics. And then we need some handlers. No handlers. We need a body, which is our flight. It's sent up in the payload. Yeah, by default, we get the concat operator, so we don't need to mention it. But now we need some handlers like on success and on error. On success gives us the result, and if we need it, the former parameters. The result here is also a flight, which is now batched over the current flight. Because, when saving data, it might change, and so we need to write it over the current flight. Perhaps we got a new ID or we got some calculated properties, stuff like this. So what's going on here? Result. Let's call it flight. No, flight. Oh yeah, that's a good one. The flight lives in the resource. And if the resource is in place, we don't have flight, but we have flight value. We had it before, didn't we? So this is what the resource is doing. And this shows another nice characteristic of the resource API, namely, we can directly batch the value that comes from the resource. By the way, the resource value is by definition writable. It's not written back to the backend. It's writable because also here we need a local working copy. So the ideas behind this are similar to the ideas behind using a linked signal in the former example. The resource can act as a local working copy. Okay, in addition to this, let's call the snack bar. Of course, we can argue whether it should be allowed to directly use the snack bar inside of a store. I think I would rather abstract it, have something like an application service with show message. But for the sake of brevity, here I'm directly going with the snack bar. And here I'm saying flight saved. Okay. And when it comes to the error state, I say error saving flight, and let's write out the error to the console. So I guess quite often you will not need an error handler, because when there is a mutation in place, we also get an error signal. And this error signal can be bound to the UI or used inside an effect that displays the snack bar directly in the component. Yeah, and that's it. So now let's try it out. Let's go outside to our flight edit component. And here we can now say this.store save flight. We can pass in a flight. We get this for free because our request also needs a flight. One more time, we see how powerful the TypeScript type system is here. So this will one more time be the flight in our flight form dot value, and that's it. Besides this, I could ask now the store whether this save operation is pending. There is save flight is pending. We also get it for free by the with mutation API. We have a flight status that tells us whether it's pending or whether it failed or whether nothing happened so far, stuff like this. And if there is an error, we get an error. So here let's go with pending, and in real world we would also do something with the error. That's why I mentioned before, usually you will not have an error handler in a lot of cases. By the way, if we one more time look to the store, this is really stream aligning everything. We don't need directly use flattening operators. We don't need to nest streams. We just write down what we want to have. Okay, cool. Now let's try it out. Let's make Metropolis of Graz, which should be the official name. We are in Austria, so it's of course delayed. Let's save it, and yeah, flight saved. And you see, I'm already using the is pending stuff for a loading indicator. It flashes up for a second, but if we throttle everything a bit, you see this beautiful loading indicator. I really love it. I have to do it one more time. Isn't it beautiful? By the way, if there is an error, here the error message from the error handler comes up. Okay, perhaps we don't want to display this operator if we are really quick, so that it is not flashing up. And for this one more time, we can make use of debouncing here. So for this reason, let's debounce save flight is pending. Debounce signal for, I don't know, 300 millis, something like this. Yeah, looks good, doesn't it? So now let's see whether it was indeed saved. Let's go back to flights. Let's search for, what did we have? Graz and, I don't know, was it Hamburg? Let's search for Metropolis. No Metropolis, come on. Here it is, Metropolis of Graz, yeah. So it was Vienna before. Let's edit it back to Graz. It's not delayed. Let's go back to the flights. Let's update this. Let's update this. Oh, Metro, okay. let's update this, and yeah, now you see no metropolis of Graz anymore, but Graz. Okay, that seems to work. By the way, it would be nice to somehow have a possibility to refresh the view, because if I go in there and if I change this to 1 to 3 Graz, and if I go back, I don't want to have the old state here. I directly want to see 1 to 3 Graz, or perhaps it should be filtered out. It's up to you. So for refreshing the state, we could now use the refresh method from the resource. This is the last thing I will show you. For this, let's go into our flight booking store. In there, let's add a method reload. And now you will see something that is really cool. We have here flights reload. It starts with an underscore. It's added by with resource, but it's private because not everyone should be capable of reloading our stuff. We want to decide who and when this will be done, by whom and when it will be done. Here I'm exposing it. And so now we can go back to our flight search component. Inside of search, we can say, hey, store, let's reload the data. And also when we come back to this route, we can also force it to do a reload. An alternative to this would be some eventing, where one store tells the other store, hey, I've saved something, please update this or that state. It's a bit more performant, but also a bit more difficult to implement. And I guess this is a topic for another webinar. But now I'm really complete with this example, and I really love this example because it nicely shows how everything fits together, how the store, signals, resources, and mutations, also forms, fit together. By the way, if you like this webinar, you will also very likely like our architecture workshop, which deals exactly with those topics. We start with maintainable architectures with a good project setup. For this, we are using strategic design and X, Sheriff, micro frontends. And then we go on with reactive architectures, and we will show you all of the stuff you have seen here, but a lot of more stuff. You will learn how to implement your own custom features and extensions for the signal store. You will learn how to apply several state patterns with the signal store, and you will learn a lot of the signal store in the view of architecture. The idea is that here you learn everything you need for implementing and planning long-term maintainable solutions. We do the English version now in the end of September, and there is also a German version. So let's have a look to the English version. Here you see this guy that sometimes looks out of my mirror in the bathroom. Don't know why he watches me washing my face and brushing my teeth, but yeah, this is him. And if we scroll down, we see all the information, the key data, some pictures, the agenda, where we do a lot of stuff with architecture and X monorepos, but also micro frontends and signals and state management. There is a bonus chapter about performance tuning and a bonus chapter about security architectures. Both nicely tie into all the other topics we are discussing before. Yeah, some statistics, and here you can book your ticket. Click here and book it now. And if you are a bigger group, then you even get a better price. Cool. So that's it. So check this out. if you liked all of this. And now it's time for the Q&A. So let's have a look into all your questions. I'm starting at the beginning. We have a lot of people here from different places. That's really awesome. Yeah, greetings back to Poland and Angola, Silesia. Good to see you, Lukasz. Bonjour from France. Bonjour. Brazil. Oh, wow. I got an out of the scope questions here. Those are the best, if you ask me, the out of the scope questions. When can we use NgRx signal store in Angular 20? As there is currently only a released version for Angular 19. Well, the thing is, since several weeks already, there is an official version for Angular 20. I used it today in my examples. I used the newest Angular version, so there is indeed a signal store version called 20 dot something. Yeah, by the way, Michael, good to see you here, and thanks for all your hard work for the toolkit, for the NgRx toolkit. Michael is really putting in a lot of effort and energy to make the toolkit a nice and good and high quality open source project. Yeah, so if it is provided in root, it's available globally, which is fine. Lightweight stores can be used for both global store, global state management, and local state management, but perhaps you don't use it everywhere. Quite often, you directly use it inside of your feature or inside of your domain. And if you have some access restrictions, you can even avoid that someone outside of your scope is accessing the type. And if they cannot access the type, they cannot get hold of the service. So this is really fine. But yeah, you can also provide it locally in the sense of the component store. Yeah, what are the benefits of declaring flights in with resource rather than in with props? So that's a good question because that shows that you are an early adopter, and you are right. Before we had with resource, we needed to put the resource into the properties using with props. This is still possible. However, it adds a lot of boilerplate. And as you have seen, with resource gives you a lot for free. For instance, you have suddenly all those flags like, is it loading? Was there an error? And so on. So you don't need to deal with this by yourself. So it's a bit shorter, a bit more nicer integrated. If someone of you using this in production, because I'm imagining the huge code base that needs to be established, is it possible to make more than one of those stores for one component? Yeah, totally. So all of this is quite new. I mean, the resource API is still experimental. The mutation API landed this weekend. Ryan and I really had an awesome weekend of doing software development, so it's quite new. I have already used a predecessor of this mutation API in an internal application, and some of our customers are already using the resource API. It's still experimental, but if you start today with a new application, and if you know, well, development will take several years, then perhaps you want to get started with the newest APIs. I don't think that a lot of stuff will change in the resource API, but the Angular team has all the possibilities of doing so as it's an experimental API. It's kind of a bet. The bet is, what is more hurtful? Is it more hurtful to start now with an old API and to migrate it to the new API? Or is it more hurtful to start with the new API and adopt it to breaking changes? So at the end of the day, this is up to you. And it has a lot to do with your culture, with your company culture. If world breaks down, if you need to change the name of a property 20 times, or if the world breaks down, if you need to wrap an if around using the value because the value can only be used when there was no error. But yeah, I can tell you, I've already used it and our customers already used it, and it really feels well. It's a really nicely, thoroughly thought through API. Yeah, you can have as many stores as you want. And if we talk about lightweight stores, then usually you have many of them. One per feature, or perhaps even several per feature. Here I'm not sure, but I know IntelliJ sometimes has some hiccups with typings because it's caching data. So please make sure you purge your cache and please make sure you have all the updates in there. This can help. Yeah. So Signal Store has been around for quite a time and it's really used in production out there. What's new is the new resource integration and now the mutation integration. So thanks for this, Daniel. Yeah. By the way, if someone of you wants to do an interview here on this channel, feel free to contact me and then we can talk about all your stuff you implemented with modern APIs and all your decisions you did. So if this is interesting for you, for instance, Daniel, reach out to me. Yeah, Mike is also using it in production. Not unusual for a component to use multiple stores. Exactly. Yeah, this is another flavor using them like the component store in the past, which is also fine. It has consequences. It will live and die with the component, which might be okay, which might not be what you want. So it depends. Both works, yeah. That's an interesting question. You have seen before, I was tunneling through the store to the component. So each signal from the store I needed became a signal property in the component. That's why we had a lot of delegation code like flight equals store.flight, ID equals store.id, and so on. I usually do this because I don't want my template to know that much about the neighborhood of the component. The law of Demeter, don't speak to strangers or foreigners. But if this is fine for you, you can totally access the store in the template. I've seen both out there. There are reasons for both. So just discuss in your team how you want to do it and then do it in a unified way. Yeah. Same answer here from Daniel. Great. Very functional, yeah. In both ways, it's a functional API. And yeah, I know at first glance, it looks like some people reinvented classes with functions. However, when you look at the extensibility, then all of this makes sense because this design, this functional design, makes it easily possible to just augment our store with new features like with props or with resource, with mutations. Yeah. So if we want to go with HTTP resource, then it's usually constructed within a data access service. And the answer to this here is yes, partly. So if you don't need the behavior of Rx method in terms of dealing with RxJS, signal method is the same. I would not say it's a replacement, but quite often instead of using Rx method, you can use signal method together with resources. Yeah, and Michael is saying the same. So it seems like we are on the same wave, which is great. If RxJS will get optional, I think Angular has to ship with a helper for debounce. Yeah, yeah. So same here. I also think so. We don't want to implement debounce in user land. Or perhaps we will stick to RxJS for that. Let's see. Let's see. If it is, by the way, for a root service, we don't need to destroy anything. But yeah, if it is not for a root, then it will be destroyed. And there is also an undestroy hook in there in the store. How can I elegantly load data by API in store, but only after the data from the other store has been loaded correctly? Yeah, this is also an interesting discussion because it shows now as we are moving away from Redux, now as we have several stores, sometimes they need to interplay. And for this interplay, we have several possibilities. One of them is one store could directly inject another store, which is quite direct. It's straightforward, but we have this tight coupling. And this might lead to a situation where the system is not that controllable. But it's a possibility. If you have layering, perhaps it's not that an issue if a higher level store is injected in a other way around, if a higher level store gets a lower level store injected. But I think this would not be my first choice. Another good option would be eventing. So perhaps we have some event service with an observable, with a subject, and this allows us to send around events, and some stores consume those events and do something. And meanwhile, there is a Redux layer on top of the signal store you can also use for eventing. It's called the Event API, but it's more or less the Flux pattern, and it feels like Redux. But officially, it's the Flux pattern. Should I call a method from the other store? Yeah, this is the direct solution. You can also use a signal from over there, or you can go with events. Sometimes you can also put a service in front of 2 or 3 stores, and then this service will orchestrate them. Yeah. So if it is without events, then perhaps a service on top. I think this would be the cleanest solution there. Otherwise, events. Yeah, we can also use inject flight service, but not everywhere because we need to be in an injection context to call inject. The method itself is not in an injection context, but you can use an optional parameter. This is how we did it before with props. We just added another parameter that had a default value, and the default value was pointing to inject this or that. This would be possible. Just do this in another parameter. Well, if we want to load in parallel multiple data, then the first question would be, is it the same data or is it different data? If it is the same data, we can just tell several stores, load this, load that. Perhaps we have an event for this or even a facade that is delegating to all those stores, and then they will work in parallel. And then we can compute our final state, our completion state that says, well, our completion signal is true when all of the other completion signals are true. This is one possibility. If you want to call the same loader several times, or if you have some complicated synchronization logic, merge map, switch map, orchestrating different flows, then you still need to go with RxJS. So RxJS is not going away, and it's really, I think, a beautiful solution for this more complicated kind of things. For simple things, we can just use simple stuff like resources and the mutation API. Lukash is asking, in Signal Store, if a component shows an item by ID from the route, can I inject the router into the store? Yeah. So you can totally do this. You can inject the router in the store. You can use the router within an hook, within an on-init hook. Perhaps if you find out you already did this 5 times, you can write your own custom extension that is synchronizing selected parameters from the router with state in your store. Yeah, totally. It's also a question of taste. Some people really like to have the store communicating with the router. Some people say, well, the store should not be aware of the router, then they pass in the values they got from the router. But both is totally possible. Isn't it an anti-pattern to inject the router into the store? Well, I've discussed this with several people. It's not my first choice, obviously, or honestly, but some people are doing this. I mean, with their NgRx store, we had this router store, which was doing the same. I think if we do it, somehow we need to abstract the communication with the router. We should not need to know too much about the router. We should just need to know that we need a parameter with this name. But yeah, it's possible, and you can nicely abstract it away with a custom extension that is doing the mapping for you, for instance. Yeah, Michael says it's not necessarily an anti-pattern, yeah, but I could see an argument for that. Yeah, so one more time, we are on the same wave, which is really awesome. Personally, I make a service where I sync router state using our X resource signal method in the component. Yeah, this is also my style, but I have also seen that some people inject their router into the store. Awesome. What's the advantage of with mutations and HTTP mutation over using Rx method? Well, it's a bit shorter to write. You don't have nested observables. You don't need to deal with flattening operators, at least not if the default concat map is fine for you. And you get some signals. The current operation is described by signals like an is loading signal, a status signal, an error signal. So you're more in the signal-based world. Of course, you can do it with Rx method, but this would be a bit more boilerplatey, and you will find out quite often you do the same stuff inside of Rx method. HTTP mutation, and with mutation is abstracting that away. However, if you look inside of those here, they are not completely different inside to Rx method. They work in a quite similar way. How does the caller of safe flight in with mutation know if it was successful or failed? Awesome question. So we really discussed a lot about this very topic because there are two situations. Sometimes you have fire and forget. Sometimes you tell the store do something. Then the store is doing something, updating the state, and then you just display the new state in the component. But sometimes you really need to know whether the triggered operation worked. And it's even more complicated than it worked or did not work. Because if we use switch map semantics or exhaust map semantics, it also can get cancelled. And for this reason, a mutation returns a promise that informs you how it ended. Did it end well? Did it end with an error? Or was it aborted? So you can just use this promise if you need to know this. In my example, it was more fire and forget. It was more like this unidirectional data flow, sending up an intention, doing something, getting new values down. Yeah, it's basically a wrapper. You can completely do it with method or with the Rx method, but then you will find out you have to write the same stuff time and again. You have to introduce signals representing the current state of the operation, like was it successful or not, and yeah, this boilerplate is taken from you with those extensions. Where do I found the better debound signal version? Look up Alex Rickabo's Twitter timeline. He posted about it some days ago. From what Manfred says and from what I see, you no longer have to deal with complex RxJS operators to handle errors, successes, and so on. Yeah. At least not for simple use cases. Yeah. It makes simple cases simple. And for complex cases, we still have the power of RxJS. What I'm missing with the signals is a more direct back channel for mutating data. Like when I update the flight, I want to navigate away. Yeah, this was exactly the use case I had. This was why we also added the promise. So if you call an mutation, you get back a promise, and this will inform you how it ended. Yeah, really awesome, because this was part of our discussion, a big part of it. You can do GET requests. GET has not the semantics of mutating anything. It should be idempotent. However, if the API is designed with GET in mind, no one can prevent you from using GET there. Yeah. So it's possible. You can set each and every possible thinkable and unthinkable HTTP verb. Can I integrate with resource hook with entities? Let me think. And the answer is not directly currently. Not directly currently, but perhaps someone who is maintaining a library with extensions for the signal store will bring something like this up. We will see. Nikita, since I will take quite some time until we get signal forms and upgrading a big enterprise project is not instantly done, do you have any tips on using current angular forms with signals? Well, yes, I have some tips. And you are right. You will not start updating an existing solution now. If you start with a new solution that will be implemented in the long term, you might want to get started with the newest APIs, but otherwise, very likely, you will not update it immediately. One thing is, as signals are a reactive building block, it works better with reactive forms. You have less issues if you go with reactive forms. You can also make it work with template-driven forms. Here, quite often, you need this linked signal we have seen today to get a locally working copy you can bind to. So I would say favor reactive forms. If not possible, use the linked signal track we've discussed before. Well, what is the benefit of using the signal store instead of a normal service with signal properties? I completely feel you. At the end of the day, both is the same. At the end of the day, a signal store is just a service with signal properties. The big benefit of the signal store is it takes a lot of boilerplate away. For instance, it automatically gives you a signal for each property you have. And from the outside, this signal is read-only. From the inside, it's writable. Also, if you look into with resource and with mutation, it takes away all those boilerplates. It immediately gives you a lot of signals for the current state and so on. So it will be shorter. And all the people in the team will be forced into a way, pushed into a way where you work unified. I'm curious about the design decision behind suffixing the state of the mutation, various using a property. Yeah. So this was also a big discussion. I think, but perhaps Michael knows more about this, providing nested properties here would not be that easy. But Rainer told me there are some discussions about this, about providing nesting in that way. And yeah, people are asking for this time and again. In HTTP resource, how we can intercept errors in the store instead of HTTP resource error in the component. Yeah, so there is no official mechanism for this. The HTTP resource is more state-based, so you have to look at the errors property. You could use it in an effect, or you could use an HTTP interceptor or a global error handler. Those are your possibilities. If you use an Rx resource, you have even more freedom. With the signal store, we cannot use Redux DevTools anymore. Yeah, this is an interesting question. And another reason why you really should use the DevTools. Because as part of the NgRx toolkit, you also get with DevTools. just add it at the end or somewhere else in your store. Provide a nice name, like this is the flight booking store. Sotre store. And then in your application, you will immediately see your store here as part of the Redux DevTools. Flight booking store with a filter, with some loaded flights and so on. Nice. So the DevTools got you covered. No, usually there is no speed penalty from accessing the store directly from the template. It's more a question of architecture. Should your template need to know about the neighborhood of the component or not? That's everything. Interesting point. And yeah, the resource by default has switch map semantics. By default, it has switch map semantics, which is usually what you need when searching for data. And if you need more, you can switch to the Rx resource. Let me look if there are further questions. And the answer is yes and yes. You can use Rx mutation and also the RS resource from a real stream like a WebSocket. This was also an important part of our design in the mutation, but also an important part from the design of the resource. There is something like streaming resources, and an Rx resource is a so-called streaming resource. This is actually a good question. You showed moving the creation of the HTTP resource to a data service. How can we do this with mutations? Yeah, let's quickly do it. It should be part of the solution we are going here with. So my service already has this prepared. Here I have a create save mutation function in my service. It takes some options from or for the mutation, like I'm sending a flight up and I'm getting back a flight. And in here, I'm just spreading in those options to my HTTP resource. And then here I'm defining my request. Very likely those options contain a success handler, an error handler, or a different flattening operator. So if we move back to flight booking store, then now we can predefine this a bit. No, flight detail store. Here we can predefine this a bit. By calling store.service.create save mutation. And here I need those two guys. And yeah, that's it. No protocol details anymore inside of our store. Let's double check if it works. Metropolis of Graz. Flight saved, yeah, looks good. Metropolis of Graz, 300,000 inhabitants, so I think you can really call it Metropolis. Just kidding around. Okay. Awesome. Thanks for this question. Greetings from Tyrol. Hi. We use HateOS to get the API links learned from your workshops. We need to wait for the API links, especially for a resource. Well, in this case, you would trigger the resource, and at some point in time, it will give you a value. And then this value can be used to construct the parameters for another resource, if I understood this question correctly. Because if I got it correctly, the second resource needs some links from the first resource. As everything is a signal, you use computer to go on and to convert the result to the second request. Yeah, I will send out everything tomorrow morning via email so that you can play around with it. Do you recommend using SOT? And yeah, I really love SOT, and it nicely plays together with the resource API, and I think starting with tomorrow with the mutation API. It's a feature we discussed today, and so we can implement it. It's just a matter of 2 lines of code for us so that we can use SOT or any other scheme library together with mutations and resources. Yeah, I thank you. It was really a pleasure to have all of you here, to have that many interests, to have that many people that are as enthusiastic about this as I am. I thank you. Yeah, so you can access the webinar at a later stage. Tomorrow in the morning, I will send out all the material, the link to the recording and my examples and my slides so that you can play around with it. And yeah, if you have any questions, feel free to reach out to me. And don't forget about our workshop that takes place at the end of this month. It's completely remote and interactive. We have a lot of examples where you see stuff like this and even more goodness. So big thanks for joining, and see you around.